Hello everyone. Today we will be learning about the fundamental principles of fiber optics. Before you watch this video, I highly recommend that you watch my video on refraction to fully understand how fiber optics work. This is a fiber optic cable. It uses light to transmit data across long distances as light travels insanely fast. It is also used in home internet systems for lightning speed and performance. There's a lot that goes on inside this cable, so let's take a look at the components first. There are three main parts that make up every fiber optic cable. At the center is the core, a thin tube made of a special type of plastic. This is where light travels through when we transmit data. The second layer encasing the core is the cladding. This layer serves a very special purpose, which we'll talk more about later, but it's basically a silica layer that traps light inside the core so that it can travel through the core. The outermost layer is called the coating, and this layer serves as a protective layer to protect the cladding and the core from outside debris, light pollution, etc. It's generally made out of a type of silicon. Now that we understand some of the basic parts of an optical fiber, let's take a look at what happens inside the fiber. Imagine the innermost tube as the core of an optical fiber. Remember that it is a tube of solid glass-like material. On the outside of this core is the layer of cladding we talked about earlier. Now let's imagine a device sending out a single ray of light into the fiber. When it hits the edge of the core, the light refracts. We talked about refraction in a previous video, which you should watch if you haven't already. The link is in the top right corner. To sum it up, due to the difference in the material used in the cladding and the core, it changes the speed of light as it passes through each material. This causes the light to bend or refract. I'm going to use the term index of refraction, which I covered in my refraction video, to describe how much the speed of light changes through a particular material. The core is made of a material with a high index of refraction, and the cladding has a low index of refraction. This means that the light will bend a lot when it hits the barrier, and since the differences in the indexes of refraction are so great in an optical fiber, the light will actually bend so much that it bends back into the core. This is called total internal reflection, and it is a fundamental concept that allows optical fibers to work. This happens every time the light hits the edge of the core, allowing light to travel far distances through the core. We can also introduce another ray of light that travels at a different angle through the core. If you imagine each ray of light representing a stream of data being sent, this means we can send multiple streams of data down one single optical fiber, which increases the data transfer rate. This type of optical fiber is called a multi-mode optical fiber because there are multiple modes or streams of light that we can send down a single optical fiber. There's a slight problem with this though. Look at this green ray of light. It bounces up and down the core very frequently, while the orange ray travels with less bounces. What if we introduce another mode or ray that travels perfectly straight? Clearly, if we extend this cable over long distances, the green would arrive last and the blue would arrive first. This means that if we're sending data over long distances, the data would get all mixed up and out of order, which is not what we want. This is called multi-mode delay distortion. One way to mitigate this is to limit the length of these multi-mode fibers to prevent significant distortion. Multi-mode fibers typically have a maximum distance of around 500 meters. Additionally, many long-distance fiber optic cables only use one mode, erasing this distortion, and this is called a single-mode fiber. There are other issues that arise with optical fibers, because although we can achieve total internal reflection, imperfections in the materials used allow some light to escape out of the core and disperse or get absorbed by the material through heat, and over long distances, the signal strength will start to decay. This is called signal attenuation, and is defined as the loss of signal strength in networking cables or connections. One way to mitigate this is by using a device called a repeater. The device is placed periodically along a large length of fiber optic cable. It decodes or reads the light data, which has weakened but is still readable, into binary and sends out a strong beam of light with the same binary code or data. Repeaters slow down fiber optic data transmission and aren't super cost efficient. Most fiber optic systems today use amplifiers, which contain optical fibers that have doped cores, which are cores pumped with chemicals, and boost the intensity of the light signal. This removes any latencies that repeaters would cause and are much more cost-effective. Fiber optics supply the internet and transfer data across the entire globe. Giant fiber optic cables run through the oceans to connect continents, as shown by the blue and yellow lines in the map here, which connect the world together digitally. Additionally, fiber optics are used in the medical field for endoscopies, where the fiber optic cable allows light to travel through bended tubes. Clearly, Fiber optics play a huge role in our modern society, and without them, communication from one side of the earth to another would take way longer than it does currently. I hope you have learned the basics about how this amazing technology works and can answer some of these questions I have on screen. If you haven't already, check out some of the other videos I have on optics related topics. Thank you for watching and see you next time.